Trying to figure out where you are and where you're going has always been a challenge. Navigation and positioning are crucial to so many activities, and yet the process has not always been easy. Thankfully, the days of navigating by celestial means or landmarks are long gone since the introduction of GPS, or the Global Positioning System. So what is GPS? For some answers, I spoke with Dr. Kevin Dutton at NASA Langley to find out how it works.
GPS stands for the Global Positioning System, and like the name suggests, it's a system to find your location anywhere on the Earth or near the Earth's surface. And the way it does that is by using radio frequency broadcasts from orbiting satellites.
Can you tell me why GPS was originally developed?
It was developed by the Defense Department to meet all of their navigational needs. For example, aircraft and ships at sea. And now even individual soldiers carry little receivers like this in the field to find out where they are.
The Global Positioning System consists of a constellation of 24 satellites and their ground stations working together. GPS uses these man-made stars as reference points to calculate positions accurate to a matter of meters, and in some cases centimeters. As long as you have a GPS receiver and a clear view of the sky and a map, you'll never be lost again. Today, GPS is finding its way into cars, boats, planes, construction equipment, farm machinery, even laptop computers. So how does the system work?
Let's say you're backpacking and you have a receiver with you. You're going to turn on that receiver. Now the GPS satellites are constantly broadcasting a signal, all 24 of them, but above you at any one time there's only 12 available, and then the other 12 are on the other side of the Earth.
Okay.
So your receiver is going to listen and try to find at least 4 of these satellites directly above you, and then it's going to determine a range to each satellite, and it's going to use those ranges and the known locations of the satellites, and it's going to do some mathematical calculations and a process called trilateration, and it's going to figure out where that GPS receiver is. That'll also give you altitude, and it'll give you speed and the direction that you're traveling in.
A standard GPS receiver will not only place you on a map at any particular location, but will also trace your path across a map as you move. If you leave your receiver on, it can stay in constant communication with GPS satellites to see how your location is changing. With this information and its built-in clock, the receiver can give you several pieces of valuable information like how far you've traveled, how long you've been traveling, your current speed and your average speed. Also, the estimated time of arrival at your destination if you maintain your current speed.
There's a lot of uses that they hadn't really thought about when they developed the system. For example, later on it was discovered that if you put multiple antennas on a vehicle, like an aircraft for instance, you could actually get attitude. You could figure out its orientation and whether it was rolling or pitching or yawing. Other things that they didn't realize they could really do were, for instance, seismologists use it for earthquake detection and to find out when tectonic plates are actually shifting apart. It's that good.
Something else.
Yeah. Very interesting.
Sure. So that's how it works. So the next time you want to know where you are or where you're going, don't reach for a map. Reach for your GPS. Now, which button is it here to press for a date for tonight's gathering at 3?